Hello, today I'm going to produce a video to show you how to plot graphs on Excel and to put in the appropriate error. Okay, so these are the data that we have collected from our scientific method experiments. We have the control group people and the exercise group people. What we did was everybody measured the heart rate for a minute beforehand, and then the exercise group people exercise rigorously for a minute and the control group people just stay put, then these time points indicate the heart rate that are measured immediately after 0 minutes. And then we collected two more data points, okay, two more time points of data, 5 minutes after exercising and 10 minutes after exercising. The control group people can also measure the rate, okay, without exercise. That's 0 minutes, 5 minutes, and 10 minutes after the Okay, so here are the data that we have collected. Okay, so I'm going to show you how to plot graphs properly. So the first thing we want to do is actually to compute average. Okay, so we want to compute average of the people in the control group and the average of the people who are in the exercise group. So to do average is very simple. So what you want to do is simply hit the equal sign and then type in the command average. Type in the command, type this phrase average, average. All right, and then you open the brackets, then you see it wants you to select the range number. So you then move over to the range of data. In this case, I'm going to average all the data in the control group or exercising. Highlight this whole range of data. You can check whether the range you've selected is correct, B4 to B14. You can see here, this is row B, on B, row 4. And then you hit close the bracket. And then you hit enter. That computes the average for you. All right, so after you have completed one square, okay, it's actually very easy to copy over the command to the next few columns. Okay, so what you want to do is move your mouse down to the lower right corner, and then you can see that the arrow actually turns black, right? When the arrow turns black like that, a black arrow like that, just click on it, right? Regular left click, and then drag, click and hold, and drag to the other three columns. That actually copies over the command, the next column, and you can actually click on it and check now. You see now in this column J, you're now averaging the data from C4 to C13, right? Then in column K here, the data are being copied, is now doing the average from B4 to D13. Okay? Same here, you can see here now doing the average from E4 to Okay, now we have computed the average for the control group. Let's compute the average for the exercise group. Right, so I'm going to click over here, and then you do the same thing, hit the equal sign, and then type AVERAGE, open bracket, and then I'm going to select the data range. So in this case, it would be from this the row 20 to 32, and then I'm going to close the bracket, enter. Okay, so after you've hit enter, I can do the same thing. You can see here, I'm going to scroll over to the lower corner of this cell, and you can see that the arrow turned black, and then you click and hold it and drag it to the other column. Okay, so just for to make the data look a little bit more neat, what we can do is we can actually change how many decimal places it can display. But what I want to do is now highlight the entire section, and then I'm going to right-click it. When you right-click it, if you scroll down to Format Cells, all right, and this panel shows up, General, Numbers, Currency, Accounting, etc. So then you want to click on Numbers, and then you can select how many decimal places you want to see. Okay, the default is 2, but in our case, we can say 1 decimal place. That would actually make our data look reasonably neat. Okay, so here you go. So these are the data that we have rounded to 1 decimal place. So after we've computed the average, we need to compute the standard deviation for both the data from the control group as well as the data from the exercise group. To compute standard deviation, you want to use this command. Okay, you want to hit the equal sign 2. Then you want to type in stdev dot. Okay, there are actually two standard deviation. You see, the one dot p says population standard deviation, and the second one dot s says deviation based on a sample, ethnological value and text in the sample. So since these are data that we collected, okay, so I would prefer to use the standard deviation sample. So stdev, then open bracket as well. And then you want to select the data range that you want to calculate the standard deviation from. In this case, I'm going to go to, okay, from C4 to B4 to B13. So that would calculate the standard deviation of its range of data. You also want to do the same thing to the next three columns. So you can repeat the same command. So what you want to do is you want to go to this lower right-hand corner again, okay, of the cell. And then when the arrow turns black, you click on it and hold and then drag to that of three column. Right, so now I have computed the standard deviation of the data from the control group. So now we're going to compute the standard deviation of the data from the. I'm going to do same command, equal sign, stdev dot s, open bracket. All right, highlight the data range, close the bracket, hit enter. All right, and once you've done the same thing, you can copy and paste the command to the next. You can use the same thing. All right, just to show a little bit of variation, what you can do is you can also hit Control C for copying and hit Control V for copying over the next column. You can also do the left click copy, click on it, and then right click and then paste. That would do the same thing. Or you do what we just have done before. Go back to the lower right hand corner and drag to the next. That will also copy the command over to the next column. Okay, now we have actually constructed both the average and standard deviation. I can also fix the standard deviations to display the appropriate number of decimal places. So I would also highlight the whole range and then go to format cells, and then I would then say select one decimal place display as well. That makes the data look more. It won't affect how the data are being. This makes it a little bit less cumbersome to look at. Okay, so now we are ready to actually start plotting graphs. So I'm going to show you to plot two types of graphs. So we're going to do a column chart. So what we want to do is highlight the data, all right, the entire table. So you notice I've actually named the data correctly. You see control group average, exercise group average, and I've labeled the corresponding a label for the column. So before exercising, 0 minutes, 5 minutes, and 10 minutes after exercising. So you actually want to highlight the entire data range. Okay, so if you put in the correct heading and put in the correct label beforehand, Excel would actually automatically put that information into. Okay, so then you want to highlight the entire table. All right, and then you go to insert. All right, insert. There are various types of graphs you can choose from. Okay, so we're going to try to do column chart first. Column or bar chart. Okay, we're going to do that. So you can try 3D column, you can try 2D columns, but just to make it simple, we do 2D column first. But you can also select to make 3D column on that kind of representation. Right, so 2D columns worked for us. Okay, so I don't recommend doing a bar chart, horizontal bar chart like that, but it's customary to put data in with the dependent variable on the y. All right, so we're going to do this 2D column. Okay, so we're gonna. All right, so now you can see that this is our chart. Okay, so I can make it a little bit bigger so that we can do some editing to it. Okay, now first of all, let's give it a nice title. Okay, you click on the title and let's change the name of the title. Instead of chart title, let's say you can give it any appropriate title you want. You can say heart rate before and after exercising. Okay, or choose any other appropriate titles. Okay, now the next thing I would like you to do is to add the axis title. Okay, so what you want to do is to simply click the chart. Then you notice on the right hand upper corner, it says chart elements. Okay, so click on chart elements. Activate the axis title first. After activating the axis title, you can see here these two things pop up. So I'm going to label the y-axis as heart rate and BPM, okay? Beats per minute, that's my unit. And here I would say, you can simply say time, I would say, all right, time after. Okay, so now you can see here the Excel program actually already tell you that the blue column is the control group average, and then the orange column is the exercise group. You can now tell the exercise column does indeed look quite a bit higher after exercising. The heart rate of the people who does indeed look higher after exercising. All right, so the next thing we're going to do is to incorporate some error bars, okay? Now, the error bars that we're going to put in, okay, represents kind of the data range, okay, from the group of data that we've collected. So now standard deviation is actually quite good measure of that. So we're going to try to put the standard deviation that we have calculated on the data we've collected onto the chart, okay? So, and put that as the error bar. What you want to do is click on the chart again, go back to the chart elements, okay? This time you want to go to error bars and activate it. Activate it first, okay? What you need to do is go to the arrow, and then when you click on the arrow, you see a couple of things: standard error, percentage, standard deviation, more options. Now, this standard deviation is not the standard deviation that we've calculated. It's whatever default standard deviation that Excel decides to put in. So don't do that. What you want to do is to go to more options. When you go to more options, it will ask you add error bars. Eventually, you want to add both, okay? So we'll just stick with the control average first. Okay, now you see format error bar comes up. When that comes up, there are three icons here. You see there are fill and line, shadows, okay, and then, but you want to stay vertical error bars. That's where you want to be it, okay, vertical error bars. Once you've selected vertical error bars here, keep it at both, okay, because you want both up and down, okay. And then you will select custom and then go to specify value, okay. After you have selected specify value, this little window will pop up. It will say positive error value, negative error value. Now we actually want to put the same readings in both the upper and lower error bars. So what you want to do is simply click on it and then click on the positive error value first, get rid of whatever that is actually on it, and then go highlight the data range. Okay, now we're doing the control group, so I'm going to do the standard deviation for the control group. I'm going to do the same thing for the negative error bar. You want to get rid of whatever that is in that window. And then go select the standard deviation control group. So you see the positive and the negative error bars should actually be the same values. Okay. Once you've done that, you see you can check here and said sheet one, from row IA to LA. So these two should be identical. Okay. So you need to click OK. Ta-da! You've actually incorporated the error bar in the control group now. All right, so we haven't really done it correctly for the experimental group. So I'm going to now click on, if you actually rest on the error bar itself in the experimental group, you see series, EX group average Y error bar. So you want to click on that. Once you've clicked on that, then you can also go back to custom and then specify value again. Now this time we want the error standard deviation that we have calculated for the experimental group. So I'm going to do the same thing, click on the positive error bar, get rid of whatever that was on it, and then highlight these four Okay, so that's the positive error bar value. And then we're going to do the same thing for the negative error value. Get rid of whatever that's on it, and then highlight these four. Again, it's for the standard deviation that we've calculated from the exercise group. Okay, all right, now we have successfully incorporated both the error bars to both the control group and the X. All right, so this is actually a pretty good chart. Okay, so now why don't we try doing the same thing and add and do a line chart, but doing exactly the same thing. Okay, so I'm going to actually try to maybe open, try to do another chart, but same information just to show you how to do that again. This time I'm going to say, I'm going to highlight the data range too, okay, with the labels. And then let's try a line chart this time, okay? So we're gonna try a line chart this time. Okay, this 2D line chart like that, that looks good, okay? Not 100% stacked like that. Okay, this line chart with marker, it's also good. Line chart without marker is good. So let's try the line chart with marker. All right, so this is the same information, but represented in a line graph, okay? So I'm gonna make it big. All right, so to go through this exercise again, okay, you can fix the chart title again. All right, so I'm going to say the same thing, heart rate. Okay, and then you also need to activate the axis title again. So click on the chart elements, do axis title. Okay, and then I'm going to change the name of the axis. Now you always want to label your axis properly. Okay, so otherwise people have no idea measuring. So heart rate beats per minute. Here will be time after X. I already have the label 0 minute, 5 minutes, 10 minutes. I don't have to put minutes here. Okay, so now we want to do exactly the same thing again to put the error bar. Okay, so so you want to go to chart elements again and then activate error bar once again. Click on this arrow, go to more options, and it'll tell you add error bar based on series, control group, exercise group. We do the control group first, and we do the exercise group. All right, so now for whatever reason, it's not showing me the error bar options. Make sure you go back to this icon here, error bar options. All right, leave it at both. Then you want to go to custom. Specify value again. So this is the positive error bar. So you want to get rid of what's on it. Okay, and then highlight the data range or the control group. Now, same thing for the negative error bar, highlight data range for the control group. Remember, we're now doing only the control group error. Click OK. All right, now you can see that the experimental group also have error bar written already, but that's not the real, that's not the appropriate error bar. It's just some default data by Excel. So you want to click on that. All right, click on the actual error bar, go back to custom, specify value, and click on the positive error value. And then now you want to put these four data, the standard deviation that we've calculated for the experimental group here, and then do the same thing with the negative error bar, highlight the data range like that, and then select OK. All right, so basically, essentially the same information but presented in two different formats. Okay, so now it's actually very important that you show the error bars. Okay, so that is actually a good way of telling others, you know, what is the range, what's the inherent variation that you actually do from your data. All right, now let's actually do some statistical analysis. Okay, now we are trying to ask the question whether exercise okay, will indeed increase your heart rate in a significant manner. Okay, so if you just take a look at the average value, okay, so you know, before and after exercising, now it's quite clearly that right after exercising, your heart rate has gone up, but you see after 5 and 10 minutes, it's come back down. Okay, whereas in the control group, there's a little slight uptick, but really not much difference in value after 5 and So, but to employ an objective standard to see whether a set of data is indeed the same or significantly different from the other set of data, we would employ a simple statistical test. So I would use the t-test right now, okay, commonly called students t-test, but it's actually very good for analyzing grouped paired data like that, okay? But here's what I'm going to do, okay? So I'm going to click on this cell here. So I've already pre-written a column that says, a row that says t-test control group, t-test exercise group. So what we're going to do, we're going to compare the data that we've collected right after exercising with the data right before. And then we're going to compare the data 5 minutes with before and data 10 minutes after exercising. We're going to do, let's do the first one first. So let's do the 0 minute first. So I'm going to hit the equal sign and type in the command TTEST. Type in TTEST. That stands for t-test. All right, and then open bracket. Now when you see open bracket, you see array 1, array 2, tails, and type. Array 1 refers to the first group of data. So we're going to highlight the data beforehand. All right, and then you're going to type comma. Then array 2, we're going to highlight the range of data that we've collected immediately after exercising. And then hit comma. And then the next one, tails, asks you one tail or two tail. Now leave it at two tails. So I'm going to type 2. All right, and then you type comma again, and then it asks you to make the fourth selection. 1 is pair, 2 is 2 samples with equal variance, and then 3 is 2 samples with unequal variance. Since we know these data are actually paired, okay, it's the same person's data before exercising and 0 minutes after exercising. So these data are actually paired. So I'm going to type in 1. Okay, so you type in 1 and then close the bracket. And then you hit enter. All right, now we get a value that says 0.16. Okay, what that means, this is actually a p-value, a probability value. A p-value of 0.16 actually means there is a 16% chance that these two sets of data are actually the same. Okay, so t-test tests for what we call a null hypothesis, meaning whether the data are actually the same. So when I have a p-value of 0.16, that actually tells me there's a 16% chance that these two sets of data are actually the same. Okay. In other words, okay, it's just by random chance these two sets of data. There's a 16% chance that these two sets of data are the same. So that to most scientists is what we call not very significant. Okay, it's because most scientists would actually agree that, or if you need to get to a p-value of less than 0.05, in some case even less than 0.01. Okay, for the two sets of data to be considered significantly different. Now, if you get a p-value of 0.16, okay, most statisticians and most scientists would actually say there's not enough evidence to show that these sets of data are different. Okay. Anyway, so let's try to compute the p-value for the data we've collected 5 minutes after exercising compared with the control group. So we're going to do the same thing. So we're going to hit t-test, okay? All right, now this time we're going to highlight the array 1, which is before. Now, and hit comma. And then we're going to, array 2 right now, we're going to select the data in the 5-minute range. All right, and then you type comma, and then leave it with 2 tail distribution, 2, and then these data are also paired, so 1. Close the bracket, hit enter. Now, you can see here, this p-value is 0.26, okay, which really shows that there is a 26% chance or so that these two sets of data are the same. When you get a p-value that high, that means that these two sets of data, okay, there's a good probability that these two sets of data are really the same. No significant difference between these two sets of data. So I'm going to do the last column too, t-test. Open bracket, array 1 is still the before. Sorry, I'm going to highlight it again. All right, array 1 is just these. All right, and then array 2, now the data at 10 minutes. All right, distribution pair test again. Hit enter, and I'm getting a p-value of 0.46, okay, which is a really high p-value, and then that is definitely not a significant. All right, so now we're going to try to do the p-value for the exercise group. So we're going to do the same thing here, equal sign t-test. Array 1 is the data before, so then comma, and then array 2 is the data for the exercise group right after exercising. All right. Then two-tailed distribution, also paired data, close the bracket, hit enter. Now I'm getting a very, very low p-value. Now 3.7 to e minus 10, that actually means 3.72 times 10 to the power minus 10, okay? The number 3 is a 10th decimal place, okay? So that means there's a 0 point and then 90, and then the 3 is actually in the 10th decimal place. Okay, this is an extremely low probability value. All right, that actually means that the p-value that comes out here is telling us that if the chance that these two sets of data are the same, are actually extremely low, okay? The chance that these two sets of data are the same is actually extremely low, okay? The probability of that happening is 3.7 times 10 to the power minus 10, okay? And extremely low. As we've said before, if you get a p-value less than 0.05, or in some more stringent cases, less than 0.01, that's considered having statistical significance. So I'm going to do the compare the data we've collected 5 minutes after, compare with the before. I'm going to do the same thing, t-test, open bracket, highlight the array 1, the data before, and then the data we've collected at 5 minutes. Comma again, two-tailed distribution, 1, the pair test, equals 5. Now I am still getting a pretty low p-value, p-value of 0.0007. Okay, this p-value suggests that there is a 7 out of 10,000 chance that the data we've collected in 5 minutes, these compared with the data beforehand, these two sets of data are the same. The probability is still very, very low. All right, so in general, the lower the p-value, the more significant differences there are. Okay, so scientists generally use a bar of 0.05, and in some more stringent cases, 0.01. Okay, if the p-value is less than 0.01, definitely there is significance. Okay, so we're going to do the last column too, equal sign, t-test, open bracket. Okay, array 1 is the data before, comma, and then array 2. All right, the data after we collect in 10 minutes, two-tailed distribution, 1, a pair test, hit enter. Okay, I'm still getting quite a low p-value, p-value of 0.005. Okay, all right, that's 5 out of 1,000 chance that the two sets of data are actually the same. I still find there is actually still significant statistically significant differences in heart rate in the exercise group 10 minutes after exercising compared with the heart rate. Okay, so that is what we are trying to measure here. Okay, now, so this hopefully gives you a quick idea how to make graph in Excel and how to use a simple student t-test to determine if the two sets of data are indeed or the same. All right, so just for curiosity, I'm going to show you one more command. Okay, now if you want to compare the heart rate of the control group and the exercise group before the exercise, you want to test whether these two are the same or different. So I can also do t-test. All right, now this time array 1, I'm going to try control group. I'm going to hit comma, and then array 2 right now, the exercise group, comma. I'm still going to do two-tailed distribution, comma. But now in the last case typed, since I'm now preparing the heart rate of the people in the control group versus the people in the exercise group before exercising. Okay, these data are not paired. Okay, instead I'm going to have to select number 2 here, 2 samples of equal variance. You can kind of assume that because we are, it's within the population, you would assume that the variance of the heart rate is more or less the same. So we're going to select 2 in this case. Okay, that would actually help us analyze to see if the people in the exercise group, naturally have a different heart rate than people in the control group. So 2, 2 like that, close it. All right, now I'm getting a p-value of 2.9. Okay? This actually suggests that there's a 90% chance that these 2 sets of data are actually the same. Okay, so that means that these 2 groups of people have a very similar basal heart rate to begin with. So that's why we don't see any statistical difference. All right, so this actually yields some very valuable information. So if you want to convince people that you have indeed, okay, that the treatment that you or the experiment that you indeed have a significant difference, okay, indeed show a significant effect, you do have to do some simple statistical analysis, just this student t-test to prove that to convince people that your data are indeed significantly different. So in this case, you can see that exercising will indeed cause a significant rise in heart rate, okay, even 10 minutes after you have stopped exercising. Okay, so all right, so I hope you find this video useful, and using Excel to plot graphs is actually very useful. So I hope you would enjoy using Excel and apply the knowledge you've learned to go on to do other things as well. Okay, so thank you very much.